Hello, this is Gary Marr of Arizona State University. This screen capture is from my IFT 101 online class. In this screen capture, I want to talk about a couple of examples in Python that implement arrays. One is a single dimension array, and the other example is a parallel array application. So we'll start with a simple one first. This particular array is called name array, and it has 3 values. You can actually initialize an array in Python as being empty and then append values to it as you go, because remember, an array is essentially a collection of values that share the same name. Each value is called an element. The element is accessed via a subscript. So in this case, I have an array called name. It has 3 values: Wilma, Barney, and Fred. Those are also the elements. In the subscripts or indexes for these values would be names array sub0, sub1, sub2. I've initialized a counter as 0 for reasons you'll see in just a second. I've got some headers out here I'm going to print out for the display purposes. And then I'm going to have a while loop. You're going to find that while loop and for loops, especially for loops, do very well with arrays, because typically what you're going to have to do is move through the array subscript by subscript. So in this case, I'm doing what's called a linear search. The linear search simply starts at the first element and continues to the end of the list. There's another element that's talked about in the book called a binary search. And in this case, you have to have a sorted array. And this is a very good technique for very large arrays. For small ones, a linear search is fine. But if you can just think now, if I had an array that maybe had 500 values, and if they were sorted, what I could do is I could check the middle value of that list and see if that's what I was looking for. And if I was looking for a number, let's say it's a number 55, if the middle value of the entire array list was a 70, I would know that the element that I'm looking for must be in the first half of the array. So then I would cut that first half in 2, and then I would search that, find it's in the second part of that. And what happens is, rather than having to look at every value until I actually hit the winner, the binary search will save you a lot of time. But it implies that you have a sorted array. And we do have a bubble sort example as part of the class notes. I'm not going to go through it line by line, I don't think, but I'll let you look at it. It's out there in the module folder with these other 2 examples. But that's something that's available with a binary search. Most of the stuff we'll be showing here are linear searches, which simply are moving through the array subscript by subscript. And again, that's what's so nice about a repetition structure like a while loop or a for loop. So in this case, it's going to start off at element 0. And a nice handy thing you have available with Python is a length function. And what a length function tells you is how many elements are in the array. So if this starts at 0 and I have 3 elements in my array, it should go 0, 1, 2, which would describe the subscripts for each one of those 3 elements. So all it's going to do is print out some information about each element as it moves through the array. So the first one's going to print out the name, print out count of 0. And it's going to have a name of Wilma. And then it's going to check. Okay, it's going to say, is that particular value that just came through Barney? If it is, it'll say found it, and it's going to print out some information. If it isn't, this does not have an else. Remember when I covered the decision structures, I said many if statements do not have elses. This only has a true. If it's a false, it'll come down to increment the loop. Do not forget to increment the loop, because otherwise you've got an endless loop. It's going to sit there for hours. And now it's going to look at the second value. It's going to say, okay, is the second value Barney? Well, yeah, it is. It's going to say found it. It's going to put all this information. Then go to the next one. And the last one's Fred. It's not Barney, so it's going to still read it, but it's not going to process against it. Now, what you can do is that I could have added an else at the end, excuse me, not an else. I could have added a break. In fact, it's commented out at the end of this list. And all this would have done is, I said, as soon as it finds Barney, if that's the only occurrence of that name in the array, then I don't have to look any farther. I don't care about Fred, who was the 3rd entry, so I can use a break statement to take me to the bottom of the while loop and let me exit out of my while loop. So if I execute this, there's nothing really terribly fancy about it. Let's try this again. Oh, it's right there. Let me clear the display. It's just overriding what I had. There it is right there. There's my first element, 0. My second, Barney, which actually has a subscript of 1. That's what I'm looking for, so it prints the message. It also does the Fred. If I comment that, or if I take a comment out of that one, and I run this again, what you'll find is it stops at Barney, because it found the one I was looking at, and then simply exit the loop. That is a cleaner way of doing it, but again, it's a way for me to give you an opportunity to demonstrate the break statement that's available with Python. Most languages support break and continue. We don't have anything with continue and looping, but that's also another option. All continue does is go one more iteration. All right, of the loop. So let me move on to the second example here. This is a parallel array. And essentially what happens in parallel arrays is you have two arrays with the same number of elements, and they're built based on a relationship that exists between the two. And by that I mean this array, which has excuse me, a key field of 1 corresponds to Mark, 2 to Joe, 3 to Sally. Don't confuse these with indexes or subscripts. They're just values. So I have a numeric in here, and I have a string in here. And what it's going to do is it's going to do a search for a particular value, and when it finds the value, it's going to print out excuse me, whatever subscript that was. Let's say it's Joe. It would print out subscript 1, Joe, from this particular array, and subscript 1 here, which is a value of 2, and that would show up in this line here. The only thing that's different about this one is, there's another example below here. This one is an ascending. So in other words, it moves from the top, or from the very beginning of the array at the 0 element to the end. The other example moves from the back to the front because it's decrementing. Okay, and I talked a little bit about this with my while loop lecture, video lecture, and I said you could also not only increment but you decrement, and that's what's happening there. So when I run this, again, this is not terribly exciting to watch because it isn't really using a lot of case or real life information as much as is a demonstration of how the program flows. This is an excellent one to put through the debugger though, because with so many branchings and so many nested structures, if I put the debugger on this and follow the code, it really is very enlightening in terms of how this stuff works. I've always maintained that with any programming language, Python included, if you have a debugger, online help, you can pretty much figure out how it works by checking keywords, the effect on the data values, or the variables, I should say, identifiers, and also by how the code is moving through the program, the flow of the program itself. Well, hopefully this helps. I will tell you there's also an example in that module folder in the Canvas files that goes through bubble sorts. In bubble sorts, most of the time what happens, any search or sorting you do is going to be done with arrays. We just did a search there of a single dimension array and also a parallel array. In the case of a sort, what ends up happening is it's usually two while loops, and those two while loops coordinate moving through all of the data and shifting the position of the values around so they're either in descending or ascending order. The example that I put out there on the in Canvas and files will allow you to kind of play with that some. It works a lot like this. It doesn't really have a real-world application as much as it is an example of how the code is structured and how you move through the code to actually get it in sorted order. So I'll let you look at that on your own. I won't cover that as part of the video for now. If you have any questions, let me know.